Number 24, an at-will machine is presented by the above diagram. What's the magnitude of the acceleration of the 0.5 kilogram block? All right, so let's do a free body diagram. We have, well, I'm going to call the 0.5 kilogram mass 1. So its downward weight would be m1g, and it has a tension force going up, and it's going to accelerate in the upward direction because the other mass is much heavier. So let's get a different color for the other guy. Its downward force is m2g. Its upward force is the tension force, and its acceleration is in a downward direction. All right, so let's sum up the forces for M1. So we have the summation of forces equals M1A because the acceleration is positive. The forces going up are tension force. Downward would be M1G equals M1A. So our tension force is equal to M1G plus M1A. Now if we look at the other mass, the mass 2, we can sum up its forces too. Summation of forces, but now since its acceleration is going down, it's going to be a negative M2A. Tension force still going up, the weight pointing down equals negative M2A. Getting tension force by itself, we have M2G minus M2A. Now when we compare these two, we have tension force equal to this, the same tension force equal to that. We could set them equal to one another. So we would have M1G plus M1A equals M2G, let's get some room, minus M2A. Since we're looking for acceleration, let's get acceleration on one side of the equal sign and everything else on the other. So let's leave M1A on this side and add M2A to that side. Leaving M2G on the right, we can subtract M1G from that side. We can factor out the acceleration since it's common to both of these terms. And divide both sides by M1 plus M2. And now that we have acceleration all by itself, we can plug in our numbers. So mass 2 is 0.75 times g, which would be 7.5, minus mass 1 times g, which would be 5, over mass 1 plus mass 2, which would be 1.25. When you do the math here, it comes out with an acceleration equal to 2 meters per second squared. Don't have the choices, but 2 meters per second squared is your answer.